Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Stephenson from the University of Copenhagen, who's working with a number of people on a project called NEXT. Christian is incidentally partially supported, at least, by Microsoft Business Solutions in Copenhagen, formerly Navision. And what he'll be talking about today is a component in the NEXT project that deals with understanding formal commercial contracts.
Okay, thank you very much. As Jakob said, my talk today will be about formal commercial contracts. And first of all, I should stress to say that this is work in progress. We still have some odds and ends to do, and we're working on putting the whole thing together and probably getting an article out about this stuff. So this is joint work with Jesper Andersen, Ebbe Esbo, Fritz Hendlein, and Jakob Bruce Simonsen. So, here's a short program for today. I'm going to motivate why we want to talk about contracts. I don't want to be working a lot on problems that nobody has, so we want to make sure that somebody out there actually has a problem and we're able to solve it. So I'll be talking a little bit about the domain, and we've got a lot of analysis on that domain to see what are the actual contracts out there. I would also interleave with that a little bit about the REA model. It's an enterprise model, foundational enterprise model that allows you to basically model every event that takes place in the enterprise. We'll be using that, or at least a little bit of that, and then our own contract model and the syntax and the semantics of that. So, short introduction to the NEXT project. This is a project I'm involved with. It started in 2001, and it has 3 partners. It has Microsoft Business Solutions, formerly Navision, and they're working on 2 generations of enterprise systems at this point. Also, we have the IT University of Copenhagen, a relatively new institution that has 40 employees, of which 3 full-time professors are working on the NEXT project. And there are 2 PhD students and a number of master students. Also, the Department of Computer Science at the University of Copenhagen. This was founded by Peter Nauer, if that name rings a bell to anybody. This is where he took his first professorship in 1970, and we have about 30 full-time researchers in this institution. And this is a wide range of mostly theoretical computer science and algorithms, databases, semantics, programming languages, that kind of stuff. Whereas the IT University straddles between business, organization, sociology, and computer science. And we also have a homepage. It's on it.edu/next. So, first of all, the most basic concept that we're talking about today is that of a contract. So what is a contract? I'll be using that term slightly more generally than you otherwise would. I would say a contract is simply an agreement to do or not do certain things. I won't require a contract to be a written piece of paper or anything like that. I'll simply say contract if there is an explicit or implicit understanding between a number of parties to do something or not do something. That is a contract. And that leads me to the following postulate, namely that contracts are used every day by companies in basically everything they do. Every time they interact with the world, there is an explicit or an implicit contract that governs this communication. So, the interesting thing about contracts is the fact that they have or may have a huge impact on the company that has contracts. At any point in time, to do my planning, I would want to be able to know what are my future obligations. Can I take this huge order in, or maybe I'm full, maybe I don't have resources, or I should talk to my suppliers and make sure that they actually have the ability to send in more more products. So contracts are necessary, and especially contractual obligations are very necessary in planning and reporting. I also want to tell my stockholders, I just signed a huge contract, this company's going up, stuff like that. And problem is today this is handled in an ad hoc fashion. Contracts are mostly captured on paper, if they're captured at all, and then for that reason we have no chance of actually monitoring the contract. Are we going according to plan, or are we not? Or do analysis on contracts, maybe. More elaborate things. So we want to see how far we can push the envelope in terms of putting contract handling into enterprise systems. And this is what this is where we come in. So a bit about the contract handling in practice. So there's a number of problems that can arise when a number of parties engage in contracts. The first point I had, disagreement on what events happened. Might be a simple thing as, I sent you $100, no you did not. Simple thing like that. Maybe we can do something about that. There will also be disagreements on the semantics of contracts. I just heard recently that there's a legal dispute over the 9/11 event as to whether it was one event or two events. Apparently that has an insurance impact. So we want to make clear that both parties agree on the semantics of the contract.
And you're going to solve that then?
Why not? This is the whole scheme of things, and we'll just, point to some of those we may be able to solve. The 9/11 one is definitely not one I plan to solve. So, and there will be the disagreement. This one is kind of tricky. You have to see a contract to realize that this one exists. Both parties agree on what happened and what are some of the semantics, but still the contract is non-deterministic. Maybe two clauses specify that a payment must take place, and you have to say which clause is actually the one getting active at this point. Point number 4 is probably the place where we can have the largest impact on the mal-execution of contract. An anecdote from eBay told me that there's a major European bank that has 50 million losses per year, 50 million euros per year. And that's divided pretty much into 25% on the semantics of contracts, legal payments for that kind of stuff, and 25 simply for the mal-execution. Deadlines expire, you don't react to options exercised, that kind of stuff. So there's a lot of money to save if you actually formalize these contracts, put them into a system, and have monitoring and execution of contracts. And surely there's always the problem that right now you have paper contracts and they're divided all over different areas of the company, different departments. I can't really get an overview of what are my obligations for the next half year, and that's a fairly important question to ask yourself when you're managing a project or an enterprise. So the goals for...
Can I ask you a question?
Sure.
So let's see, so a contract, in the way you think about it, is not necessarily something that's already formalized, is it?
Well, that's what we're trying to do, really.
Yeah, you're trying to do that, but I'm trying to understand what phenomena in the real world you're trying to capture. I mean, in one extreme, a contract could be something very informal, like a bunch of people getting together in a room and having a conversation about we want to do this and that. That would be like, just a working group. Any sort of process that involves some exchange of data or objects could be regarded as potentially a contract, although it's not specified. So when I hear the word contract, I'm thinking of something somewhat more formal, something that has a bunch of rules.
Yeah.
Things like deadlines, money flowing.
Exactly. I will require...
Things that don't sort of...
Yeah, I will require that there will be some sort of specification governing the execution of this contract.
Okay.
All I'm saying is this specification may be implicit. So when I go to the doctor, it's implicit that I get treatment and he gets payment, even if we're not writing a contract. That's what I'm saying. But it also, often it's very explicit. Often you have 40 pages of legal stuff, writing out every single possible case of what can go wrong. So the goal of this project is to write a domain-specific language for contract specification, and hopefully this will give us, first of all, flexible user-specified contracts. Sounds a bit like a cliche. The thing is, a lot of contracts can actually be composed. I have maybe standard terms of sale. Once those are specified, I can use that, plug it into every other contract I use, and they can be arbitrarily complex. And most importantly, I want users to be able to do this. I don't want it to be a programmer sitting writing the ERP system. It could be a partner actually implementing an ERP system with a customer, or maybe it's just the customer him or herself. Also, we want to be able to execute them automatically. This is very important in relation to the points I just had here, disagreement on what events have happened. If I can actually automatically execute a contract, that is to say, have two systems and have them both sit there with the contract and send messages or transmit monetary resources, for instance, across, it will be a lot easier to obtain non-repudiation because we will have fixed protocols for handling these things. And deadline management is an obvious plus, because I will have a portfolio of contracts just sitting there, and I will know exactly what my deadlines are and what am I supposed to do at this point. Reporting on contracts, or even real-time reporting. As I said, right now we don't have reporting on contracts, so if we can push the envelope there, it will be immensely useful. And I would say this one here, contract analysis, is really interesting. It's difficult to see at this point if that's actually possible. Doing valuation on the contract, that is to take contract and give an assessment of what is the value of this contract to my company at this point in time. If we cannot probably not uniquely identify the exact value of the contract, but we will be able maybe to give decision support tools on that. And then obviously when people are writing contracts, sometimes they go wrong, they write a contract that doesn't make sense. It would be nice to be able to just have somebody say, help, something's wrong here, this contract allows for this particular train of events that we wouldn't like to have. Okay, so right now we'll just now the focus a little bit and say, what we want to do is we want to take commercial contracts, that is contracts that deal with the transmission of resources between companies, and we'll only focus on the happy path. So what you asked before about, am I going to settle the semantics of contracts? No, I'm not. What I want to do is execute contracts. I want to make sure that contract can be automatically executed as long as everybody agrees. If people do not agree or disagree on the semantics of a formal contract written in this language, we still have to get in the lawyers. Okay. This is our first example of one such contract. This is the simplest one I could find. Yes?
I'm a little concerned about the word. Sometimes people mean that to say that I'm not going to worry about the exceptions or untoward things of any kind that might happen. That's not what you mean. I think what you mean is people are not going to make malicious misinterpretations of what is written, rather than that I'm only going to look at everything going right as opposed to anything going wrong in the way I write the code.
Okay, yeah, I see what you mean. So the happy path here is just to say that we want to focus on the normal execution of contracts, but I'll still be able to see if something is not normal, if there's a breach of contract. I'll be able to identify that. What I'm saying is I do not wish to model the process of going to court and settling.
No, that's not court, but for example, return of goods, right? You sold me something, the goods were defective, I'm going to return them to you.
Okay.
It could be very well a part of the contract. It's not happy in some sense.
Okay, don't be just don't take this too directly. It's not happy in that sense, but it's happy in the sense that it's better. It's specified in the contract. Right. Okay, so I'll return to my example contract here. This is the most simple contract we could find. We took a lot of contracts out there, and well, let me just sort of do an analysis of this contract, identify what the entities are here. So I'll point to the word point to the word seller here and say, there's actually somebody, a legal entity of some sort, that has the discretionary power to do something. We will call that an agent. And I also have description of goods. So there are resources. This is just very simple ontological analysis leading up to a foundational model we'll be using. So I'll just sort of justify that, but I won't go too deep into it. And well, there's sell and deliver. Those are verbs. Those are some events that these agents can carry out. And we have, well, the consideration. Then there's another party that has to do something else. So the foundation here is microeconomics, in the sense that everything that companies do is the exchange of scarce resources in a market. Okay. So this leads us to the very simple model called the REA model, proposed by William McCarthy in 1982, and he basically says that all that enterprises carry out can be modeled in a very simple pattern, namely, an agent affects a resource in an event, and this will be the pattern we'll be going for. Simply saying this is what happens. Every time something happens, there will be an agent, there will be a resource, and it coincides pretty well with what we've seen in contracts so far. You want to be a little bit general on resource. A resource does not mean physical product. It could mean a service, or it could mean a right. So I will transfer a right to somebody. And well, these are the. I will not give the full definitions, but you can ask me afterwards if you're interested in seeing the whole model. The model is a lot bigger than this. Here's another contract. Again, I'd like to point to a few things in this contract. So, well, here's a simple contract. An attorney has a legal services agreement with the company. The company will be provided any fixed hours of legal services each month. Everything in excess of that will just be billed at a regular rate. And for that, even if he spends 0 hours, his lawyer, he will still bill a fixed retainer fee for that. Okay, so this is a contract. First of all, you will see that there's a concept of a repetition. Okay, so we'll just note that and say there are repetition constructs in these contracts, and we need to be able to model that. You'll also see that time is present a number of places. It's present here in the deadline of the contract. It says this contract is only valid in this period of time. And you will also see that here, before the 8th day and before 40 days, there are local constraints. So there will be both global constraints governing the whole contract, and locally there will be constraints also on time. And then obviously we still have agents, we still have things for them to do, that is events, and we have resources to model that with. Okay, so also you'll see if I just draw a little picture of this contract here. We'll start at some time point here, T0, and we'll have the lawyer. Can everybody see this? Okay, good. And the company. And the lawyer will start providing legal services through the first month. And the company then will, at some point here, make a payment and another payment over here. While that's happening, the lawyer will continue, and so these services will be paid for in consideration here and here, and these will be paid for somewhere in the next month and there. Okay, so we also have the concept of parallel execution. That is, things can happen in parallel and you don't know exactly which thing is going to happen first. There will also be the concept of choice, in the sense that somebody here chooses whether he should bill excess hours or not. Is he working more than he should? So this gives rise to the following patterns. And you can see we're closing in on something that might look like a language here. Huh?
I missed what you said about things happening in parallel.
Okay, so the line here pretty much says that at any point during this month, the lawyer can choose to provide services. And this says that the company shall pay the consideration at some point. And what I'm saying is we need to specify that that's possible, even if we don't know if he's going to provide those services here or here. So we don't know the exact order of these things. So therefore, it's easy to just say they happen in parallel. I mean, they could have an elaborate workload down here, and they'll be working on a number of things while the other party was working on something else. So we need to basically be able to say that some events can happen in parallel, or at least we don't know the order a priori. Also,
So just for my clarity, are you modeling these events?
we will.
Events have a footprint somehow electronically.
Yeah, they will. I mean, they will at some point obviously be registered. One last point here. You'll also see at some given time, say for instance here, there will be multiple unfoldings of this contract active at the same time. This will pertain to the first unfolding of this contract, while what's happening here will pertain to the second unfolding of this contract. And there may be arbitrarily many of those. Okay, so this gives us these patterns we've identified. The sequential execution is just do this and afterwards do that. And we have choices, we have the concurrent execution and repetition. So we did this with 15 contracts, standard contracts. We just took a whole bunch of contracts that we thought were pretty commonplace and analyzed those. I've talked about these two, the agreement to sell goods and the legal services agreement, and those will be my running examples for today. So we actually coded all these with the exception of one, namely the trade law here. We thought that was...
I was just going to ask you if you were trying to formalize the entire data trade law.
Well, it's a pretty big document.
That's what I was thinking.
It's a huge document, and there's a lot of things going on there you don't want to know about. But so we tried to formalize this, and it turns out it's really difficult. It's because it's not really specifying the structure of a trade. It's more like it's a collection of exception handlers, really. It's like something goes...
Trade law is a collection of exception handlers.
It really is. I mean, something goes wrong, and it tells you, here's the remedy. And this is the underlying remedy at some point when everything has just gone stuck. So we didn't code that, but we coded the other 14. And that's what gave us the language we have today.
It's WD-40 for trade.
Say again?
Could you go back 1 second to the previous slide? I just wanted to look at those and figure out, like, okay, the Danish trade law was sort of very big, and it was sort of a bunch of exception handlers. And so maybe that was not so easy to do, but is there any one of the other items that is sort of, I mean, can I get a sense of how complicated this became?
Sure.
Cases where you were able to...
Let me tell you about another one. This the website development contract. It basically was a contract that said that there would be 10 or 12 deliverables to be made by the website producing company to those who wanted the website. And then in return there was a preposterous paying scheme in which they would pay NASDAQ stock and cash on delivery and credit card receipts and all kinds of stuff. It was a really complicated setup, and these things would depend on the exchange rate and the NASDAQ index at some point. So that was fairly complicated. There was a lot of what we call observables involved. And
was it a software project? Was that a software?
Yeah, it was a software project. It was the contract for the development of the .com website that they outsourced.
So did you take a formal document describing that?
Oh yeah, we took all 40 pages of that particular document and sort of walked through it. Brings me to the next slide. So mainly these contracts have 5 components, and we'll only be focusing on the second one that I've highlighted with the star, namely the structural description of what's going on. We won't be trying to formalize in any computer language the conditions on a contract or something like that, because, as you noted, that probably wouldn't be possible to do this kind of thing.
What do you mean by the conditions?
Conditions might be something like the weather, the merchandise has to be delivered on a sunny day, otherwise you should provide plastic packaging. And you may not want to go into that kind of detail. You just maybe want to annotate the contract at some place to say, here are the conditions for the event that just took place, and the one receiving the merchandise will be able to say, okay, so it looks good or it does not look good. I don't want to start coding what's a rainy day and that kind of stuff.
Which is exactly what I asked the question about the electronic footprint, because that's really, it's the electronic footprints of events that you can really describe.
Yeah, and this is exactly what
Sunny day is hard to describe structure.
Okay, also another thing we noticed when we looked at these contracts is basically when the structure evolves over time, or you pick a path through a contract over time, there are 4 things that can happen that governs how this path is chosen. One is that an agent has an active choice. The most obvious example of that is an option, stock option. I can buy stock or I cannot buy stock. This is my choice. Another one is time chooses. Time does not choose really. It's just a deadline expiring, and then the contract goes into another state. We also had the concept of observables. Some contracts will be governed by exchange rates or other economic indicators, and you will actually say, I want to observe that indicator at a particular day, and that will pick the path for me to go. So we need to have that in too. And then some contracts do aggregate functions on the log of events. So say, for instance, I have a manufacturing agreement, and there will be lots of things going on, and I will want to have a watch checking if the current balance at any point drops below 0. If it does that, the contract halts, for instance. So in a sense, the specification of contracts is very similar to network systems. They're communicating, sending messages, and they'll be sitting there waiting either for an event to come in or a timer to expire. It's a lot like programming in that sense. So the goal was to make domain-specific languages, and the method for doing that was twofold. One is to actually check the fit to a domain. It's a pretty good idea when you do a domain-specific language. And the other to do a semantics-driven analysis so that we had a pretty good feeling about it. It turned out along the way actually to be a very good development tool, and that posed a lot of questions that we wouldn't have seen otherwise. Okay, so here's the first. So here's the syntax for the language that we came up with. You'll see that most of these constructions are more or less copied from the slide I showed you with the patterns. First of all, we have success and failure. Those are just the contracts that contain no commitments and are either okay, everybody's happy, or failed and there is no remedy. And we also have another atomic contract called the transmit. Now the transmit simply says that some agent should transmit something to another agent at subject to some predicate P. Now this predicate P, we thought about making a small predicate language for handling time constraints, but eventually we decided to parameterize it out of the language. So P here is just plug in your own favorite predicate language. If I want a very simple predicate language that only considers time as the only predicate that can govern and transmit, that's fine, I'll just do that. If I want something more complicated that can do computations, I can plug that in. It doesn't really have anything to do with the structural description of the contract, so it makes a lot of sense to take it out of there. And then you'll see after the transmit there is a .c here. That is to say that my variables A, or my agent's resources, and the time at which an event will occur would be bound to names, and those names will be passed on in the environment to the next C subcontract. So the rest of the constructions are pretty forward. These will allow us to compose fairly complex contracts. We have a sequence of contracts, and we have a parallel composition, we have the choice, and the last ones here are particularly nifty. This is the main entrance to the language. It allows us to give a number of mutually recursive function bindings to contract sub-expressions, and then we can unfold those, reuse them, and plug them in other contracts. It turned out to be very nice.
So Let me ask you about time. I mean, there was a lot of stuff from those contracts I saw before that was highly dependent on time.
It is.
Right, deadlines and stuff like that. But if you factor that out as some sort of parametric part in the predicate language, I'm wondering, will the semantics of this language really be able to describe time dependency?
Well, that's a yes and a no, because it will, but depending on the properties of the predicate language, it will depend on the predicate language. I'll get back to that question because it's actually we still have an open problem there. Yeah.
So I don't see any talking about data dependency. It would seem to me, for example, when you say that, just as a sort of supply chain example, we have a contract for which I'm going to ship you goods, but I'm going to actually electronically send you shipping notices that says something like, I just shipped you 200 widgets, which I may have promised you 500 by such and such a time. How are you going to keep track of that?
That will be in the predicate language. Suppose, I mean, as you can see from the syntax here, none of these constructions can actually handle A1, A2, or R, or T, but the predicates would be able to do that. So the predicate can say, I want R as the number of widgets to be below 0, or something like that. So this is where I do it. I have the two disjoint namespaces. I have one namespace for functions, and that is passed around and used in this language. And then the predicate language can have a separate namespace that's passed around. So this is how we do the data handling, or not do the data handling, I should say.
Well, you can do conditions, but I wonder if you also have
I can
sums and, other things. But anyway,
we'll be getting to that. So here's the first contract that I showed you. I just coded it up to show you how it will look. There's nothing surprising here. This is the contract of me buying a burger for €4 at McDonald's sometime before July 1st. And what I'm saying is I'm using the parallel composition here, which is basically saying I don't care if I get the burger first or I pay first, as long as both of these things happen before the 1st of July. So I might even go there a few days before and just pay, and then get back there on July 1st and get my burger. This is what this contract says. And here's a legal contract. It's a bit more nasty. Let me just point to the three parts. The first part is this part up here. And this is the rendering of services by the lawyer. You will see here that he can transmit any number of hours within this month. N here is just the first day of the current month. So he can do that within the frame of that month. Or plus, as a choice, success, he can just do nothing. So that's an internal choice here. And after that has happened, there should be a semicolon out here. He will recursively do this the month after, or terminate the contract at some point.
Meta question. Why did you choose this sort of style or notation as opposed to process article, internet, and not else that you could have chosen?
Okay, so if I were to write this in say, CCS, we tried that, and it gave rise to a lot of double specification, because every time I had to do something, I would write both sides of what was going on. So this contract basically would amount to a contract for the lawyer's part, and then the mirror of that being the company. And we like the global view. We like the fact that you have one contract sitting on top of that, and you can have any number of agents functioning below that and still have one specification. But I mean, it's possible. I'm pretty sure from this you can derive a CCS-like expression for the lawyer only, if you want to.
So my related question, a follow-up question, as the presidential question says, is how do you deal with races? In other words, races. So in other words, there are there's duplex communication between, let us say, two parties that are having this contract, right? It is possible that a supplier is sending a shipping notice while the buyer is sending a cancel order message in the opposite direction at the same time. And I'm not sure what is supposed to happen in that case. And how does your common view specify the behavior?
So the common view right now says that events will come in ascending order, and only after the
Global clock?
well, something, and only after all agents agree that this is the order and these events have happened, will it be okay.
But they don't agree.
Okay, I know, but that's not really what we're driving at here.
Yeah, okay.
I definitely see that problem. Okay.
Well, the reason I brought that up is because there is an ongoing debate in the how should I call it, the process external view specification world about whether a common view is appropriate or individual compatible views are appropriate. And this sort of issue is what comes up. So.
Okay. We'll discuss that afterwards, maybe. Okay. So, well, and the rest of the parts are fairly straightforward. Here we see the company making a payment after 10 days of the next month, and lastly we see here that the lawyer will have the ability to transmit an invoice, and this invoice will be paid. And you'll see I've cheated a little bit in saying that what he transmits here is the invoice, and somehow we have the ability to address a particular field in that invoice here and make that the money to be transferred. I'll just abstract from that and say you can plug in a data model if you want. Okay, very well, and the instantiation where I call my lawyer and pay a lot of money for his services. Okay, so a contract can be understood basically as a set of traces. Let me just make clear what I mean by that. Number of events will occur in the world, and I want to observe those in some particular sequence. The sequence of events will be called a trace, a symbol one trace. So I may have a contract sitting, and some trace will occur. Contract really is a specification of a set of traces. That's it. This is how we consider a contract. This is very nice because this gives us the ability to give a mathematical description exactly of what traces am I specifying, what are the semantics of a given contract. Now the success contract basically says this contract is done, that is, it will only accept the empty trace. So it will just sit there and be happy. Whereas the failure contract will be the set containing no traces. In other words, there are no traces, not even the empty trace, that can make this contract go to success or evolve in any way. There's nothing that can be done. The rest of this is fairly straightforward. If we take, for instance, the choice first, it's just saying if we have a choice between one of two contracts, we'll just take a set of those traces in the first contract, union with a set of the traces of the other contract. So all the traces will be sitting there, and once it's executed, one particular trace will be followed through. For the transmit, it looks a bit complicated, but all that really happens here is we take a trace. It's juxtaposed with an S here, meaning that this is the first event and then comes the rest of the trace. And we want to make sure that this is actually an event, that S is a trace, that the predicate is true, and we'll give the bindings of the new variables onto the new subcontract C. There's a special notation here. When we take the parallel composition, we're simply saying we want both of these contracts to be run through. They both have a number of traces, but what we don't know is the order in which the events of each contract will happen. So this will mean that S is an interleaving of S1 and S2. Simply, if one trace is T1, T2, the other trace is T3, T4, I can have any combination of those. I can have T1, T3, T2, T4, but I cannot switch the order of those. I cannot have T2 before T1 if that's not a trace of the first contract.
Okay, so it seems that you actually have no synchronization going on.
We don't.
Okay, so this actually strikes me as closely related to what's called basic parallel processes, which is a subset of these process in which there's really no communication going on.
This is
BPP.
It's a label transition system. Yeah, so.
It's a special kind of not complicated process. It's basic parallel process.
It is fairly simple. So a bit of the semantics are missing there. It's a bit more complicated on the functions. We use fixed points and define contracts as only finite traces. So that makes the fixed point theory accessible. Okay, so now that I have the denotational semantics in place, I can write down a contract and have a mathematical meaning of this contract. But what I also want to do is be able to specify contract sitting there, an event comes in and matches. Now what is the remaining obligations? What's left for me to do? And that brings us to the question of residual contract. So I have a contract and it's been run through a trace. Now what is the contract? Is it done yet? Or are there still things I should do? So we'll use nullable to signify that the contract is completed or possibly completed. And the mathematical meaning of that is simply saying, does the denotation contain the empty trace? If it contains the empty trace, it's nullable. That is, I can claim that it's through, but that might not be the only trace. There may be remaining trace that could be carried out. And then there's the question of consistency. Do I have performing traces? That is to say, at the point I am right now, will there be remaining traces, or am I deadlocked, maybe? So I can take a contract that really has no denotation, denotates to the empty set. It will still be able to accept a few events, but then at some point you'll realize that this is leading nowhere. So actually being able to see that the contract denotates the empty contract is not entirely trivial.
So the way a contract can be deadlocked would be that some component predicate comes true.
Exactly. You need to have a pretty strong predicate language to be able to produce deadlocks in this language here. Because when you see just simple syntax and the weak predicates, you can't really deadlock. You can write contracts that don't make sense and difficult to secular deadlock, but you can't really produce a regular deadlock situation. And when we have a contract sitting there, CS, we want to be able to say an event comes in, is that a breach of contract or is it not? Okay, so the approach we'll be using to solve this is to have a reduction semantics. Simply to say, I have a contract, an event comes in, and I want to be able to produce a syntactic expression for the remaining contract, not just mathematical set already, but a syntactical expression. This turns out to be possible, and then the question I posed before, for instance, is this contract nullable, is it completed, will simply be, if I have a reduction from C with the event E to C prime, is C prime equivalent to success plus something? Because if it is that, it will definitely contain the empty trace in this denotation. And I want to know if it's equivalent to failure. That is, we've passed the point of actually being able to perform this contract. So the good thing about having this reduction semantics is that I start with a contract, I do a reduction, I get a new contract, so every function, everything I can do on a contract, I can also do further down the line after it's been running for some time. It's very beneficial. Okay, so a couple of you have already asked about this. We have here a queue of tentative events, that is to say, events that we've observed but not yet agreed on with the other parties of the contract. Once the involved parties agree on this, we'll go to the committed events. That's not working too well. We'll go to the committed events. So that'll be a queue of events in ascending order that both parties or number of parties have agreed on. This is what actually has happened. After that, we're ready to take the contract, take the events, and produce a residual contract from that if there is a matching. And whatever happens, we'll write this to a log, This log will be registering everything that happens. It will be a foundation of reports on what the company has done, that is income statement, balance sheet, all that kind of stuff. We can actually produce that from this log. And if something goes wrong, the system should be able to put out an alert and say, this is breach of contract. So this is the basic model we have. For now.
So you were saying that you were producing a residual contract. Did you say that?
Sure.
So where did that happen in the picture?
In the middle here, CPM, or contract processing.
Does that mean that I have?
Module.
Should I think of this as like saying I have an expression and a trace?
Yes.
And now I want to generate an expression
Yes.
that represents all the possible
Okay, so
continuations after that.
careful now with the all the possible, but maybe all the possible. We'll get back to that. At least I have a contract, I have a trace, and I want to see a new contract. The properties of that contract, such as is it deterministically found, we'll get back to that. First of all, just a little note, assuming that events and commitments will match one-to-one. So if it says $100 in the contract, I'll assume that the event is also $100, not $50, because it gives a slightly more complicated semantics, and there's no reason to build these things at this point. Okay, so the reduction will be very simple. I have my sale of goods contract here, and here you can see there's no non-determinism. There's nothing that really potentially can go wrong. So we'll assume the seller actually transfers the goods. That brings us to the middle of the contract here, in which the first part has succeeded, and then we'll go further down to the contract that is nullable, done, and complete. Actually, it's also the only trace in this contract. And here's another contract, slightly more complicated. You will see that the first part here is nullable, and then the prefixes of this contract, that is the events that it's able to accept at this point, are T1, T2, but if T2 comes in, this is non-deterministic. This is a problem we'd like to touch on. So we'll assume that E2 comes in, that is an event that matches either of these T2s. And if I just took any eager non-deterministic matching, it might match that in this way, and then E3 would bring the contract to fail, even if it shouldn't. So the reduction is non-deterministic, and we need to figure out what to do about this. Now, in practice, this is mostly solved by invoice numbers or any kind of ID tag to the merchandise moving around. And I would say my bet is that this will solve also 95% or more of the cases we'll see. There'll also be, in some cases, some manual matching. This is in particular if we have repeating contracts. I have a repeating contract that says I should pay $100 each month. Those $100, if 1 month is skipped, then will I want the money paid the next month to match the previous month, or should it match the current? So there will be some cases where we have non-determinism, and people handle that today by bookkeepers simply backtracking, calling each other. In the semantics, we can do a number of things. We can do explicit tagging, simply say, I can make a global call for a new unique identifier. I will get that, it's fine, and I will need the event to carry exactly this tag. Or I can do the backtracking semantics, as Jakob suggested. Simply say, if there are multiple options, I will retain them all. I will say, this one's my candidate right now, and if that one goes wrong, I'll keep a list of continuations. Okay.
You're going to suggest a cut.
Yes. So if we take the explicit control, it's just saying, I want to give a direction. I want to say right. This could be a right. It's something that guides in the contract expression, or it could be an ID. And then I'll make sure that my E2 is matched to the correct place and reduces on this side, and E3 is also reduced on the right side to get success in the way I originally wanted to. Or I can do the backtracking. Now, in the backtracking, the first thing we see here is that E2 can match both of these two, so we'll try both things. If it matches over here, if it matches this T2, it means that this was a success, it was nullable, it was then skipped, and then what remains is success plus the part over here that was untouched. Or, if that was not the case, well, then we'll take the left-hand side and that'll be unchanged, and we'll match it to T2, leaving T3 over here. And then after E3 comes in, we'll see, whoa, so this one's not able to handle E3, so it will go to fail, and the fail will be taken away, and we'll go on with the continuation instead. Yes?
If you ever want real people to see this thing, you clearly don't want to show them 15 alternatives with various backtracking options for the future. No real business person will ever make sense of this, I think, as Chris will tell you.
Sure, that's true. This is, keep in mind that this is a remedy for those last 5% where there might be a problem.
Well, actually, I think you're basically avoiding the correlation problem completely in calculus, which is the idea. That is absolutely critical to make anything work. So you cannot shove that under the rug and say, oh, that is something that somebody can do. That's the starting point of everything.
Okay. Okay, so here you see the reduction semantics, and this, well, part of the reduction semantics, I should say, and it's simply, it's what I just told, just in a more formal form. You can see that success only contains the empty trace, so it will reduce to failure if confronted with an event. Failure will reduce to failure. And for regular transmit, we'll just have, well, if the predicate is true for the names found and put into this predicate, then we'll reduce to the remaining contracts with alpha conversion and all that. And this is interesting. So if we have a contract here and the first contract C is nullable, then we will try both things. That's what I just did. There's a slight mistake here. This part down here should not be there. If C is nullable and we have C semicolon C prime, we'll just match with C, and C prime cannot be touched because C was nullable.
Why do you use there? Is that, I mean, you can't represent that in any way.
Sure, I can. See, here I have a predicate, and I can only do a matching on a transmit if this predicate holds true. So if I put my ID, my matching IDs in the predicate language, then there will be no non-determinism. Okay?
Well, I'm worried that the reduction system and so forth is kind of formalizing a relatively obvious part of the problem. And all of the hard parts are getting pushed to
Okay. Well, I think we should postpone that to discussion afterwards, maybe. Or we'll definitely discuss that. Okay, so moving on. We also have a slight problem with multiple unfoldings. That is to say, when I have a contract that repeats itself, I want to make sure that a contract like this one over here does not infinitely unfold. That is, I want to make sure that they got it. And the guarding rules are as one would expect. I would say that anything is guarded if it requires an event in order to unfold further. Okay, good. So now we're ready to do contract analysis. Contract analysis is taking a contract expression and figuring out some properties about it. Say, what's the contract worth, or how will it affect my inventory? What are the requirements for resources? How many people will I need to carry out this contract? Those kinds of questions. I'll take two very simple but very relevant, I think, analysis here, namely the task list and the next point of interest. The task list is, from one agent's point of view, what are my tasks right now? What can I do? What transmits should I carry out? And what are the deadlines of those? The next point of interest is a more global view, just for the system saying, when is the next thing that, next time something changes here. Okay, so now I need to define a predicate language, and I'll make do with a very, very simple predicate language here. That basically says a predicate is an interval A and B, and I want the timestamp to be within that interval. This is my predicate language. So the task list you'll see I've pseudocoded a bit of standard ML here. I don't want to walk you through the whole thing. I think it's pretty clear what's going on. It's very nice, though, that one can do analyses on these contracts in this way, in a computational fashion. You will see that I've defined a data type that is not here, that basically says tasks can be tasks to transmit something or to make a choice. And if there's a transmit, which there is there, if the agent is actually me, I will add that task to my list. On the other hand, on the choice operator, the plus C1 plus C2, I will say that what I have to do is choose between the tasks of those subtrees. It's just a very simple way of doing it. You could do it a lot of other ways. And next point of interest is basically the same. Atomic contracts such as success and fail do not have a time horizon. Nothing is expected to be done. Transmit, its next point of interest will be either entering the interval or exiting the interval from the time. And the rest of these are pretty straightforward. If I have a composed contract, I will want the next point of interest to be the minimum of those two contracts. Okay, so if I have my legal services, this might be the unfolding of that contract after 4 days in February, and I can do my contract analysis, see that the company at this point has to transmit a payment and to pay an invoice, and I'll also see the next point of interest is the 11th of February, at which the deadline expires. So I'm envisioning this as in a more human readable form in an enterprise system, obviously. Okay, so other analyses that might be interesting would be accounts payable and accounts receivable, to be able to see in the future what kind of accounts payable and receivables will get in, what are the money I need to pay, how's my cash flow line looking. Termination also, when it's the earliest time I can get out of this contract, the latest time this contract will terminate. Race conditions. Race condition would be a contract that allowed two agents to act at the same time, and they would both have an obvious gain in being the first to act. We don't want that in contracts. You'll see that the contracts actually out there that allows both agents to act at the same time often give them exactly the same choice, or gives one the precedence over the other if both make a choice at the same time.
That means I can't have a contract that's started in an auction.
Or the cancel thing that I mentioned, right? I mean, in the real world, if I'm a small business, then my customer can call me on the phone and make me pull stuff off the truck.
Well, but you can't.
Regardless of what it looks like.
Well, the cancellation thing is, if, say, a ship is halfway over the ocean, and at that time you send a cancellation, then it will say in the contract if it's delivered at the point where it's delivered to the ship, or at the time when it reaches the States, for instance. So I can express that particular setup, right? That is possible, but you need to make the transmission over the sea non-atomic, in the sense that something can happen while it's over there. Sure. Okay, and well, one that definitely would have a great interest is valuation, as I said, the ability to value a contract, figure out what it's worth at this point. And another area to investigate would be the general model setting of business rules. Now, we thought about how to incorporate business rules in these contracts, because if I have one business rule that applies to all contracts in my portfolio, I don't want to be specifying that over and over again. And it may be something that tags along to the predicate of each transmit I have in every contract. Now, probably, so should I do this statically, just model taking that all contracts are correct and pull a flag and say this contract is not according to business rules? Or maybe something else. We did think about having another combinator that would interleave two contracts and sort of interleave the predicates of two contracts. Okay, so language seems to have a fairly good fit to the domain. this postulate is based on the fact that we were actually able to write 14 out of 15 examined contracts. Actually to write those. And the separation of the predicate language and the contract language also seems pretty good, bar one thing that Jakob mentioned, namely the event model, the fact that time is not present in the event model. Well, that's my next point. Maybe we will want to put timer events into the event model so that a contract can sit and wait, not only for an agent to do something, but for a time tick to come at some point. For instance, this is the deadline tick. Okay, so now's the time to do something, and probably that would allow us to simplify the predicate language a little bit, because currently, if I have a predicate guarding the time in which something should happen, if I'm not able to decide that this predicate will never, from now on, and never be true, then I can't really pull up a hand and say, well, this contract has failed at this current point. So if the predicate language is very strong, I can't determine whether the predicate will ever be true again. That's an undesirable property. So maybe I'd rather have the times in the event model.
Now, if you model time like that, aren't you going to have to actually model an actual timer? Aren't you going to have to actually model a time?
I will probably need at least the notion of broadcast events. That is, that the event is not consumed only in one place, but a number of places, any number of places.
Typically, your timer is relative on an event. Typically, don't. So effectively, the timer event is triggered by another event. For example, if I send you an order, then if our contract says you must deliver within 10 days, then the time in which the order was created, the timestamp for it kind of triggers, in some sense, the timer for whatever it is. Mm-hmm. That's typically the way these things work. So it's not so much that there is a clock as that you have the ability to do some computation with timestamps and set up other future events.
Maybe.
Or like discrete event simulation.
It's not always so that a timed event would be dependent on an event happening beforehand. Maybe.
I know it's not always.
I mean, we have a number of cases where it's not. Okay. So we want to go further into the predicate language. This is future work to see exactly how strong the predicate language should be. And also, we want to explore the algebraic properties, namely how far you can push the envelope of reasoning over contracts expressed in this language. Okay, a little bit about related work that we've looked into, probably many others. William McCarthy, who made the REA's model, is also working at this point on a contract state machine, but from a fairly different perspective, I would say. Basically, he has a contract in a number of different states, and he models the negotiation process, the process of identifying partners and agreeing on a certain price. All that comes actually before the actual execution of a contract is modeled. And Peyton Jones and Mark Eber did a paper a few years ago on compositional contracts, financial contracts. So they have what we call the trading partner perspective, which we will also touch upon. It specifies the contract for one side, and there's me, and then there's the rest of the world. So it's seen from the perspective of one person. It also means it has no explicit agents. So I can't really specify that I want to send some money to this person over here and some money to that person over there. That's outside this language. And then there's a lot of, huge body of research in computer science already in CCS and the pi calculus and CSP. Fritz Henglein, who was also on this project, looked into CSP just a few weeks ago and discovered that a lot of these things are very, very similar to what Tony Hoare wrote in CSP, and he spoke about that. And there's a number of standardization initiatives, a lot of people hacking XML and figuring out protocols for the exchange of contracts. So Well, extensions, we want to look into policies. We'll need to be able to express those. And we'll also need to write out the semantics of the events, do not match one-to-one. And probably this does not have to be a domain-specific language. We can make do with a tabular form, some interface. I would dare to say. Most of the contracts aren't really that complicated, so that we need huge expressions. So I showed you the 15 contracts, and here's a bunch of contracts we cannot currently code. You'll see that the common denominator for these contracts is the fact that they change the company or brings the company into a legally different state. The company ceases to exist, or it merges with another company. People stop working there, or something like that. So it's not really governing what we would call going concern transactions between enterprises. Okay, and well, we've focused on the actualization. A bunch of people are doing the whole process here. What we might do is introduce higher order contracts. That is the ability to transmit a contract. So, and in that, if we do that, we might be able to actually do bargaining and that kind of stuff. I might send a contract to some party, and he will return a modified contract. And if I say okay, I'll instantiate the contract and we'll execute it. And well, I think we should maybe start the discussion at this point.
Okay.
So, are there any questions?
Thank you.
Okay.